So for that, here I already create the 2 decades land use land cover classification, and I classified suppose vegetation, water bodies, sand, and build up. So here I already create the 2 land use land cover map help of Landsat satellite data. Okay, so if you check, this is the map for year of 2023. This is the map for 2013. Okay, so 2 decades we find out. This is the land use land cover 2013, and this is the land cover 2023. So now I want to use the change detection between two land use land cover classification. So basically when you make the change detection, always we are just use the 2 decades. Okay, so any 2 decades we simply compare the analysis and make the change detection. So this land use land cover, how we can easily compute or create. So these things I already discussed about that, how to make land use land cover classification using machine learning. So just apply the same process for creating any kinds of land use land cover for any place in the world. Just apply the same process. Just further, first step, simply take the satellite image, then take the training sample. Okay, and further apply the machine learning model and compute, make the land use land cover classification map. So here I already create the 2 decades land use land cover 2013 to 2023. So now we try to identify change detection and make the, also talk about the urban development or urban expansion, how we can easily make. Okay, so this is the land use land cover map. Okay, so first of all we need to check which variable is stored the land use land cover map. Okay, there are the 2 variable. If you check the classified one and classified, okay, classified and classified one. So this variable basically, if you check land use land cover 2013, it is stored in the classified, and classified one, it is stored in the land use land cover 2023. So first of all we simply check these two variable. So which variable is stored in the land use land cover 2013 and which variable is stored in the land use land cover 2023. So this variable is stored 2013 and this variable is stored 2023. Okay, so now we are just use this variable, 2 variable, because it is stored the different 2 decades land use land cover. Just use the 2 variable and make the change detection. So first of all, I will try to show you that single class change detection. Suppose we are just work only for the one class and make the change detection, single class change detection. I focus only for the one class, suppose only for the build up or urban, because I want to explain about the urban expansion. Further we will also discuss about that multiple class change detection. So for the urban or single class change detection, suppose I want to make the urban change detection between the time period 2013 to 2023, basically how much urban is increased, and also identify the urban changed area. So for that, simply just take a variable. Suppose I take a variable build up area 2023 and I just call the classified one, because this variable stored the map 2023. Okay, this variable classified one stored the map 2023, then set equal to 3, because when I take the training sample for the build up, if you check the, it's just put the value 3. Okay, basically 3 is stored the build up training sample. So because so far we simply put here the 3, it's our level mainly pre-categorized. When I just make the pre-categorized data, I simply set the level 3 mainly build up, okay, or urban area. So just I call the classified one, because this variable is stored the map 2023, and set equal to 3. Basically it's the level of or value. So which class you want to identify or which class you want to make the change detection, just simply use this value. So just I put the 3 basically build up, and I want to display this map. So just apply map.add layer and call this variable, and it's a binary class, so it's create the build up and non build up. Suppose I to provide the 2 color, gray and red. So where gray, it indicating about that there is no build up, meaning non build up, and red is indicating about the build up area. So when I run the code, so it create another layer. Okay, it's represent the only for the build up and non build up map in year of 2023. So this is the process for the single class map. Suppose you want to make only for the vegetation map, or you want to create only for the water body map, or you want to create only for the build up area map, just apply the same process. Simply change the value. Okay, value. So in this case, we create another layer. So this layer is stored only for the urban or build up 2023. So we find out this type of layer. So gray color is the non build up and red color is the build up. We find out this type of red color indicating about the build up area, and this type of gray color, it's the non build up area. We find out. Okay, suppose you want to work only for the vegetation or water body, so same process, simply change the value. So when I change the value, suppose I want to work only for the water body, so water body value is the 1, so I put the 1. Suppose I will display the water body as a blue color, so put here the blue and run the code. So now it display the water body map in year of 2023 only for the water body and non-water body plus. So this type of blue color, we find out this water body, and this type of gray, this type of blue color water body, and gray is the non-water body plus, we find out. Okay, in year of 2023. So this is the process for the single class. So simply put the class value. So in this case, I want to work for the urban. So for that, I just use the 3 because urban is the 3. Just put the 3, the value, and I want to display the urban area as a red color. So now run the code.
So it just show the urban area in 2023.
Yeah.
Just one layer.
Yeah.
Okay.
Yeah. So you find out this type of result. So now I need to compute, suppose how much urban area in this place. In this place, how much urban area have. So for that, just we use this function ee.image.pixel area. So this function we simply multiply with this function ee.image.pixel area. If you want, you can also use the add bands function, no problem. Also use the multiply function because it's a image only for the build up area image. So multiply with this function, and further I want to compute the statistical value, mainly total pixel area. So it's compute the pixel area as a square meter, but when I compute the total area, then put the reduced region function. So same process, just apply reduced regions. So just take a variable, suppose urban area 2023, and call this urban area and apply the reduced region, and I compute the total area. Okay, for my study area, then define all of those and print the result. So then it display the result, how much urban area in 2023 we find out. So now if you check the result, we find out this is the large, it's a square meter unit. Okay, so further need to compute the square kilometer or hectare. So for that, simply make the conversion. So for that, just take a variable, suppose urban area in 2023 square kilometer. You can put any name as a variable, and it's a number. So I define the e dot number and urban area. So it's come from this variable, and it's get from classification. Okay, classification. So now put the divided this value and run the code. Then you can get the result square kilometer. So now run the code. So now
What is the green color?
yeah.
Which did?
So now you find out that 824.99 square kilometer area in urban in 2023. So this is the process to making the single class map after classification, and also compute the total area of this specific class. So now the same process you also apply for 2013. Okay, just I take a variable, suppose build up area 2023 and then equal to 3. Okay, because I want to display the build up area only for that, and then build up area 2013. Okay, then display the result, and now it create the another layer build up area in 2013. So it created another layer, build up and non build up in year of 2013. So we find out this is the result 2023. This is the result for 2013. Okay. So now compute how much area, same process. Take a variable and then reduce result and compute the area, and further compute the area in square kilometer. So now run the code. So now it's compute the area in year of 2013. So we find out that 586 point something, and also find out the 824 something in year of 2023. So almost we find out that 238 square kilometer area increased between this time period. So simply subtract, then we find out the result.
So I want to know, is it possible to identify the area which are common in this?
Yes. So
Yes.
so then we can easily identify using the change detection.
Yes.
Suppose in this case we find out that suppose some place have the urban in 2013 and 2023 also have the urban, so it's a common place. But when I subtract, I find out the almost 238 square kilometer area increased. So I want to identify only for the increased area. Suppose this type of place there was no urban in 2013, but 2023 there is urban. So this 238 square kilometer area you can also identify. So for that, simply apply the take a variable, suppose urban changed map, and call the build up area 2023. Okay, basically this is your this variable is stored at the map 2013 and 23. So just put the 2013. Oh, sorry, this one 2023 subtract with 2013. So now it show you the result. Suppose changed and unchanged. Changed mainly, suppose this place there was no urban in 2013, but 2023 it's urban, it changed area. And unchanged mainly common area, suppose this place was urban and also 2023 it also urban, so it's a common area. So basically unchanged area. Okay, so let's we try to display this changed and unchanged area. So now run the code. It's a two class it create. Suppose you can see the gray, it's a common area, okay, and pink is the newly set up urban area. So this type of pink color indicating about that there was no urban in 2013, but 2023 we find out the urban, this type of pink color. Okay, so we find out this type of pink color, it's a newly set up urban area. Okay, and how much area? 238. Okay, simply subtract this two value, then we find out. But you can see for the common place of urban it show the this type of color. Okay, but we find out this type of place is a newly set up urban area. Okay, see this type of place there was no urban in 2013, but 2023 we find out the urban, this type of pink color place. Okay, basically the changed area we find out this type of place. And how much area? 238. So it also more better, if you want you can also display the urban expansion. Suppose for that we can simply add different types of layer at the same time to visualize. Suppose this is the map, this is the urban area 2013, this is the urban area 2023, and when you make the historical data analysis it will be more perfect for the research paper. Suppose you want to start the analysis from 1990 and gap 10 years, suppose 1990, then 2000, 2010, 2020. So just use this type of land use land cover map and then just make the urban expansion. Okay, so in this case I just show you only for the 2 decades, but when you work with research paper or presentation for the historical data analysis, then try to apply for the more past year also. Okay, from the 1990, and then make the interval 5 years or 10 years and make the analysis. So it will be more better. So now I try to show you that how I can display. Okay, for displaying this type of map we need to it also possible you can also download this type of layer as a geotip file and also make the proper map using ArcMap or QGIS software to display the urban expansion or this type of things. But it also possible, suppose just make the single class. So if you check, it show the build up area in two class, mainly non build up and build up. So these things if you convert into single class, then we can easily get the urban expansion more perfect. Suppose build up area 2023 it show a one color and 2013 it show the another color, so then we can easily get the idea this type of place it's a build up 2023 and this type of place build up 2013. So for that just make the single class. So for the single class just use the self max function and then make the single class, remove the min and max and just use only for the one color. Okay, so now this red color indicating only for the place I have the build up in 2023. So same process 2013, just make the single class, just use the self max and then create the single class and then apply only for the one color. Suppose I just put here another color is suppose yellow. So yellow color indicating about the build up in 2013. So now run the code. So now you can see find out this type of yellow color. We find out the build up or urban area in 2013. Okay, and we find out the red color, this type of red color we find out this is the urban area in 2023. Okay, it's the expansion area or expand area, so this type of red color. But in 2013 we find out only for this type of yellow color it was urban, but 2023 we find out this type of red color we find out the urban. Okay, basically it's the urban expansion area. So you also try, suppose when you work with the 990 then just apply the same process. So it show the build up, suppose 990 is another color, then also 900 2000 is another color, 2010 another color, so then it will be more perfect for the research paper. And when you make the urban expansion just simply download the geotip file and then apply the same process, mainly simply add the layer. So you can see, so just I add the layer, so two layer I just open. Okay, 2013 and 2023. So now 2013 we find out this type of place was urban and 2023 we find out it's the expand area, it's the expand area. And you can see the common area is the overlay. Okay, common area if you check the 2023 we also find out this is the urban. Okay, but when I just open the layer 2013, so common area, suppose same, suppose this type of place was urban and also urban 2013, so this type of common area just make the overlay. Okay, so now you can easily identify this type of red color is the urban expand area. We find out this type of place urban expand area. Okay, so this is the process. We can also display this.
So
Yeah,
I
please.
want to know
Yeah.
that is if my urban area, not urban area, for something like that forest,
Same
which
process.
is no, in that case I don't know, or some parameter I don't know, it's increase or decrease. Okay, then if I use the function subtract, it can calculate accurately.
Okay, so urban. So first of all, we just make the classification. Okay, just make the classification. Suppose forest area, suppose different decades, and then we check it will be increasing or decreasing.
Or in some polygon, maybe not overall.
Yeah.
Because of some polygon, maybe it differently react with other area. Like most of the area is increasing, but some places will decrease. So if I use the subtract, then what is the output?
So basically we always, when we make the change detection, so we always make the before class and after class. Okay, suppose it increasing or decreasing, it doesn't matter. Okay, suppose when you make the classification, it always, suppose in this case, before class mainly 2023, and after class mainly past class, after class 2013. So always when you make the change detection, we always just before class minus after class. So it's one kind of formula. So any change detection, land use, land cover, anything, when you make the change detection, always before class minus after class. So then it will be increasing or decreasing. So if the result decreasing, then we find out the minus value. Okay, when you calculate the value, then we find out the minus. Okay, minus mainly decreasing or positive mainly increasing. So in this case, it's, we find out the positive value. Okay, suppose when I compute the value after some time, urban changed area compute, then we find out the positive value, mainly not negative. But when you find out the
So
negative value
if we,
after subtract, it means the decreasing the place of forest. Yeah.
okay, in this script, if we use build up area 2013 in place of 2023 and subtract, uh, just replace 23 and
Okay,
13.
okay, so in this time it's not the proper way. So if you check, suppose just I call it, just I paste here, but this formula is before class minus after class. Now it show the after class minus before class. And when you use this variable and compute the area, then we find out the negative. Mhm. So now this is, it's okay, no problem. But when you change the value, suppose just calculate the value. Suppose for that just I take a variable urban change area. So this variable just call multiply with this value and then compute the value. Again run the code. So now we find out the negative result. Let's show the zero. It show the zero. Or okay, just let me try suppose 2023 and 2013. Set the before class minus after class, then check what happened. Now let's check. I think some mistake. So we compute the change detection. Oh, sorry. This it's create the problem because I apply the self marks. Okay, self marks it just visualize only for the single class, but when you compute the calculation, then it's not work. So let me just reback the code again. Just make the binary class. Okay. So now let's try again. Suppose build up area 2013 minus build up area 2023. Let's just subtract and then calculate the area also. So now run the code. So now it find out the result. This one. Oh, sorry. Just print the result. Subtraction result. Need to print. So now let's check. We went on the negative. Negative mainly decreasing. Okay. Suppose anytime, but our formula always keep the same. Before class minus after class. Before class mainly 2023. Okay, and after class mainly 2013. So always just keep the before class minus after class. Okay, then suppose I find out the positive after when I apply this formula and get the positive, it means that increased. Okay, but when I apply the before class and after class, but I can get the result negative, it means the decrease the area.